Okay, how's everybody doing? All right, we have a really, really cool 2 presentations going on today. First one's going to be from someone you know, Roger Cox, who's our safety instructor, formerly the National Transportation Safety Board. And when Roger was here last month, talking about how the 737 MAX stuff he mentioned, I had known this, that Roger had been one of the investigators. Was it the principal investigator on the 3409 crash? You were
chairman for operational factors.
Roger. So
it was mostly an operational factors.
Exactly. And who's familiar with the Colgan 3409 mishap? Okay, it's the last major mishap actually that's occurred, fortunately, knock on wood, on the in the air transportation system in the United States. There's only been 1 fatality since then. It was the Southwest incident earlier, about a year ago. So we're on a remarkable good streak. But one of the other aspects of the 3409 is it had a big impact on all your careers, because that's basically one of the things that brought about the thing that brought about the 1,500-hour rule for commuter co-pilots. So when I found out that Roger was involved in that, I said, wow, that's a great topic for a safety awareness meeting. So Roger's back here, second time in 2 months, and I really appreciate it. And why don't I stop talking and let him start talking, because he has a lot more interesting than mine. So if you're online, make sure, if you haven't done already, that log into the chat log and just say that you're here, so that when I have afterwards, I have a record of your attendance. So give me a second to reload the slides, and we'll be right with you.
Okay. I had to use this thing last time.
Sure.
That's one good. Ooh, that works.
Yep. Try that again.
That's
Okay, Roger, I think you're up. If you want to be in the view, it's up to you. Just stand right here.
Just gonna,
and then just
have to hit the button.
tap the button. Thanks.
Good morning, welcome. Happy to be here today. He did ask me to come here and talk about the Colgan 3407. I was the principal operational factors investigator on the accident. I did a lot of the investigation, wrote a lot of the report, and wrote a lot of recommendations. It was a very consequential accident, and there are many aspects to the accident, more than we can talk about here in a short discussion. So I decided to focus on just primarily the fallout from the accident, the consequences of the accident. I'd say you couldn't know, there are 3 basic parts of the investigation. It's what happened, why did it happen, and what do we do about it? So this is the what do we do about it. Now, I gave this talk, like I said, a couple of years ago. It was Colgan 3407, 8 years after. Now it's 10 years after. Both of what is on these slides is the same. Okay. Trying not to blow anybody out here with this thing. They say catalyst accident means that this accident, more than most, generated a lot of response. Typically, there are going to be some consequences from every major accident, but the consequences of this one were really big. One of the reasons was the media coverage. This is a picture from the New York Times. A group of family members of the victims formed a lobbying group who was very influential. The media covered it relentlessly. There was a lot of pressure from a lot of parties to get to what happened here and what we're going to do about it. And then as soon as we got done, even before members of Congress got involved, because when you've got something as significant as this one, they want to know what part they should play. So here's our public hearing where we had a variety of witnesses from the FAA, from the company, from the manufacturer there. And believe me, this was had a lot of coverage from the media. One of the reasons that this accident was significant was because it wasn't just an isolated event. It was the culmination of many events. In the 1990s, the regional airlines in this country started to develop. They started to fly bigger airplanes and fly more routes, and they had a lot of accidents. So in the late 90s, 1999, I believe, the FAA changed the rules and said all those companies now have to be regulated by Part 121. That's the regulation for major airlines. They thought that would solve the problem, but it didn't. In the 6 years before the Colgan accident, there were 10 regional airline accidents. 9 of them were crew caused or crew involved. 8 of them were regional code shares, meaning they had a major airline's paint job on the tail, and the major airline sold the ticket, and the customer bought a ticket on the major airline and then wound up on the regional airline. That's called code share, and it's still an event. In fact, today, at that time, a lot of people were not really aware of what they were buying, and a lot of people thought this was a problem. So when we got to why was this important, because all of this was a prelude to this episode. This was, in my view, kind of a last straw. So we wrote a report in 1 year, and we wrote a lot of recommendations. On these slides, you can't really read them from where you're standing, but we had 25 recommendations and 3 that were reiterated from previous accidents. And recommendations, I think you all know, are not mandatory. The safety board doesn't have any regulatory authority. They don't have any punishment authority. They're not out to punish or find fault, but they do want people to pay attention and act on these recommendations, and the board keeps track of those. And so, kind of on the status there was the status. A lot of them were still waiting to be done 8 years after the accident. That's some more. Here's Public Law 111-216. This was passed only a few months after the final report was issued. This is the law that created a great many of the provisions that affect many of you today. The Congress stepped in. When Congress steps in, it isn't a recommendation anymore. It's a law. It has to be done. They said, we're not waiting for the FAA to fool around here year after year, making up their mind whether they want to do something or not. We're going to tell them to have to do something. So here's a list of the provisions of the law. I won't read them all to you, but pilot records, air carrier safety passport, review of FAA inspectors, monitoring leadership, crew pairing and CRM studies, stall and other training, air carrier training, ticket disclosure, inspections of regional airlines, pilot fatigue, voluntary safety programs, like EFOPA, ASAP and VOPA, SMS, pilot screening and qualification, ATP certification. All of that became part of the law directly as a consequence of this accident. So we had the certification, records, and selection affected. We had training, we had safety management, and we had FAA oversight and design standards all coming up as a consequence of this accident. ATP certification. We said ATP standards had to improve significantly if you're going to be an airline pilot. Part of the process requires that to get a multi-engine ATP, you have to go through a certification test program. And many colleges and flight training programs and even airlines have gone and gotten themselves certified to be able to give you or provide the training necessary. It has to be much more demanding than it used to have to be. Those are some of the locations that were approved 2 years ago for ATP training, and that has continued to expand. Why were these changes needed? Why did we get the 1,500-hour rule? In our recommendations, we didn't recommend that, but we did recommend much, much stronger certification standards in the airline pilots. Those standards have not changed for many, many decades. The Congress chose this method as one of the methods because, as you probably know, one of the requirements to get an ATP certificate was 1,500 hours of constant thought. If we have two in the cockpit instead of one, we'll have better certification standards. So that's the reason they chose that particular 8-hour requirement. Pilot records. Another reason why a lot of things had to change. Companies at one time used to do a pretty good job of tracking the progress of their pilots, not just in training, but also throughout their careers. So if we had a problem, whether they had a problem with the pilot's performance or whether the FAA or the safety board had a problem, we could usually look back and kind of see what the pattern was. But in the era of fast-growing airlines and regional airlines and the advent of a lot of electronic record keeping, a lot of that detail got lost. So when you try to go back and try to figure out what's going on with this stuff, whether it was us or whether it was the individual airline, a lot of the detail got lost in those computer databases. So it made it hard to identify people who had problems. So here's the typical computer type of training record for the accident captain. It looks pretty benign. It looks like everybody else's. And what you can see is there are some unquals hidden in there. And there are several that are missing from there. I decided we need to go back to his previous company. He had worked for a small company in Florida where pilots can come in and actually pay to fly the serious flying turboprop airplanes, and he had done that. And we went down to the cockpit and he said, "How did he do?" He didn't do very well. We said, "Well, can we see his records?" "Yeah, we can. You can see their handwritten, not a computer." And in here, we had a whole group of comments about inability to maintain basic aircraft control, inability to fly on ILS, huge problems keeping the airplane with something. But they kept him employed because he paid. And then when he applied to go to work at Colgan, he didn't bother to mention most of these deficiencies. More. Okay. So I think most of you are familiar with the fact that this gentleman had some significant problems throughout his training. He had he failed multiple chevrons. He failed 4 FAA certificate flight tests, instrument commercial ETP. The information was available from the FAA, but this airline had never tried to go to the FAA to get with that information. He also failed to pass 2 proficiency tests at Colgan. We interviewed 60 people, including the check airman, that failed him on the test. And nobody could seem to remember anything about it. I seem to think, I wonder why. I wonder why. Well, number one, they were lawyered up. Number two, company needed pilots. When it came to hiring, they looked the other way. So without stricter controls or certification, this problem was going to continue. So here's something from the Department of Transportation Inspector General, where they said really the records are a mess. And this is where they said we're going to have an FAA maintain database of the records. That's another thing we did not recommend. I still think it's a problem because asking the FAA to do anything that massive is usually very hard for them. Airlines stall and stick pusher training as a consequence of this crew's loss of control and the way that they lost control. We look back at the standards that have been applied for generations to airline pilots in particular, And the standards in the simulators were maintain altitude. You were graded on your ability to maintain altitude during the approach to stall procedure. Part of that was because simulators really couldn't duplicate an actual stall. So airlines trained you to approach the stall, and pilots got conditioned to try to maintain altitude. So many of you have probably seen this this animation. This is an animation that comes directly off of a data recorder and a cockpit voice recorder. It's not something you pull off the internet that somebody trained up, using a software program. It's the real thing. And I'm just going to walk you through step by step some of what actually happened here. So starting up here in the right-hand corner, you see 22, 16, 28. That's the time. And you can see the airplane is still flying. It's in the controls, 129 knots. This is when they get the stick shaker. They were surprised by that stick shaker. They didn't realize that it was going to come on. It came on prematurely. It came on early. This airplane was still flying. It wasn't stalled. Here you can see the power was at right idle. Here you can see the condition levels were at max. The props were pushed all the way forward. And the flaps were at 10. In a turboprop, push the props all the way up. It's like a speed brake. Pull the power back and the props up, they're going to slow down fast. And that's what he was doing. He was slowing down fast in order to be able to fly the rest of the approach because he had been fast up to this point. Here we are. And these little numbers just up here in the right hand where it says plus 4 seconds. That's keeping track of how quickly this event happened. You can see suddenly we're at 108 knots, we're up at 30 degrees of pitch, and about 30 degrees to 45 degrees of bank. He's in the left turn, but he's actually trying to control the airplane to the right. He started to push the power up, but he's pulling back. We're down to 80 knots. Shaker's on, the pusher's on. The airplane has a pusher, a nose down pusher, mechanical device, and it senses that you are in a stall. It gives you an assist. Push the nose down. The pusher was on. 28 degrees of bank, 45 degrees, or 45 degrees of bank, and about 28 degrees of pitch. That's only 6 seconds after the stall. 97 knots, over 90 degrees of bank. Ten seconds after the stall, when the first officer raises the flaps. Increased the nominal stall speed 18 knots. Still rolling back. Speaker and big pusher on. Every time he came across the top, pull back. Every time the airplane rolled to the left or the right, he released that pressure. In other words, every time he came erect, he pulled back. Why would he pull back? He's trying to maintain altitude that he's been taught. Now she's worried about pulling the gear up. Unrecoverable at this point. The funny thing is, they weren't alone. When we looked into this, we found that there were many stall events in air carriers. Over this period from 96 to 2008, there were 4 turbojet stall accidents, and I think 19 or 20 turboprops, most of them 7208s, lots and lots of stall. Number one cause of fatal accidents over many, many years, both in air carriers and general aviation, is loss of control, typically because of the stall or related to something that caused the stall. More. So this is a picture of 737-800 simulator Alaska Airlines. An acquaintance of mine at their captain, Brian Brooks, invited me in. We did some rock and roll with new software installed. The software did provide the ability for the simulators to actually simulate installed condition. And this is more of the scenario we should get into. We had other training that came about as well. This was for the problem what we call ice contaminated tailplane install. Now this airplane did not lose control because of icing, but there was an icing condition at the time. And there was a lot of speculation about whether ice caused the accident. It did not. There was a lot of talk about what we call tail stalls. And sometimes you still see that in literature because NASA put out a couple of videos in the years past talking all about tail stalls. But the pilots who watched the videos didn't even know if their airplane was susceptible to tail stalls. Most airplanes are not. This airplane was not. So it was a confusion factor. We did a forum on professionalism. Professionalism is one of the topics I try to touch on in the safety classes. A lot of discussion about what do you need as a professional? What are the attributes that you need? We talked about safety management. One of the key questions in safety management was, do we need better safety programs, safety management systems, like operational quality assurance programs, recordings, ASAP programs where pilots are able to voluntarily provide information that would not otherwise be available to the airline. And we had a discussion about fatigue. Almost 75% of the pilots at this airline based in Newark did not live in that state. They came in from somewhere else. The first officer in the accident came from Seattle. She flew all night on FedEx and then showed up in the crew room, sleeper chair to try to catch a nap before the run. So, although we didn't find that the accident was caused by fatigue, we did find that the crew did have some elements and markers of fatigue. And this particular problem of commuting is still a problem because if you get a job, maybe it's a low-paid job, maybe you're only going to be a year in a base, and it's someplace up in the North Woods that you have no intention of living there, you commute. And you move, and you change airlines, and it starts all over again. You have a lot of people, probably half the people in the industry that commute. It's a big problem. It creates a problem for the company. It creates a problem for you. So we wrote about that. BOQA, flight simulator fidelity. The simulators that airlines were using could not duplicate stalls. They didn't try. We said, with the technology that we have today, try. You should try. And after a lot of resistance over many, many years, there were some creative people, one at what we call early applied systems, going, who did find that, yeah, we can actually duplicate stalls, at least to the extent of being able to train people how to recognize them and recover from them. We're all good at things we do a lot of, but we're not very good at things we don't do a lot of. And most airline pilots install airplanes. One of the reasons you don't do a good job on go runs is because you don't do very many go runs. You're good at what you do a lot of. You don't practice it, you're not very good. Culture. Congress said the least we could do, and it is the least we could do, is we have to tell you buy a ticket. When you buy a ticket, we have to tell you who you're actually going to be flying on. That's the least you could do, don't you think? So they did the least they could do. There's the ticket. One of the passengers, it says Continental Airlines on there. Doesn't say Colgan on there anywhere, does it? Deleted. Finished modifying airline simulators for stall fidelity. That was due 2 months ago. Should be done. I'd like to know more to find out. I'm trying to find out right now how many have been modified. Complete the pilot records database. That's still pending. Complete pilot professionalism programs. Make public the list of ice contaminated tail stall airplanes, which it turns out aren't very many at all anymore. Make public the airlines that do not have focal programs. That's a secret right now. Most companies say we have a focal program, but they may only have it on one airplane or 5 airplanes. We don't know. Nobody knows. Why not? I think the public should know. And make sure that the CTP programs for your airline transport pilots are rigorous. And I suspect not all of them are. So that is, in a very quick nutshell, consequences, kind of where some of these rules came from. Not too much on what happened, not too much on why it happened. But I wanted to leave a lot of time today for questions and answers. So that's where we are. Questions, comments? Yeah.
Yeah, so a couple quick comments. Number one, we know that we've got twin engines. We get into the stall, there are a whole lot more to cover in a single plane. But even in the basic training that we receive as single engine, we know that when you're going into a stall, or when you're in danger of a stall, the last thing you do is pull back. And so I'm just kind of in my head trying to wrap my mind around how this pilot, given everything, that would be his reaction.
Well, of course, when we come up with the why, there's always an element of speculation. We have recorders, we know what they said, we know what they did, we know the training background of the individual, we know that he had more than a few times in simulator training, been very rough on the controls. So all those things were pointers to the fact that he wasn't proficient. But to get to the real question, which is why I pull back, the best explanation is this long-term FAA training standard for airline pilots, which was maintain altitude, because simulators couldn't simulate a stall. So all they wanted you to do was slow down and configure. And then the minute you got the stall warning, they wanted you to add power and maintain level flight. So it was a proficiency maneuver to be demonstrate proficiency in the simulator, but it was not appropriate training to recover from the stall. I remember as a young guy coming out of the Air Force where we stalled the airplanes left and right, when I saw this for the first time in my first airline, I kind of laughed. And what happened was most of the airline pilots, they knew this was a joke. Okay, nobody took this seriously as true stall training. He said do a stall series. Oh yeah, that's a little maneuver. We do 3 of them in a specified way. And that didn't pass because sooner or later, as time went on, you got pilots coming into the industry who don't know this. They don't know that this is kind of a joke. They think it's serious. They think what you do, if you get a real stall, you should try to maintain altitude.
Roger, would you attribute that to the change of demographics of fewer military pilots coming into the airline?
Probably. I don't know about you, but when I was in pilot training, man, we got that T-37, we spin it left and spin it right, 3 turns and 6 turns and upside down, and watch some people out. Some people couldn't handle it. It's not, for those who are a little bit faint of heart, it's not exactly something you want to go out and do. It taught you about how to stall and how to spin an airplane. And so you carry that with you throughout your career. Today, we barely stall at all. We never spin. And so now when we get into airline, work for an airline someplace, they put you in a simulator, you think you're going to teach it. They're going to get you through the program that will get you to pass an FAA-approved check ride on the airplane. So you'll do the maneuvers that they want to see, but fundamental airmanship, fundamental mastery of an airplane, they expect you to already have that. And that's a problem if you're being graded on maintaining altitude. You get a stall, which is what this guy tried to do. Yeah.
So are they actually teaching stall recovery now, or are they still doing the same?
They're doing both.
Repeat the question for the guys online.
I'm sorry?
Can you repeat the question for the guys online?
So I think your question was,
Are they now including true stall recovery training?
are they now including true stall recovery training at airlines? The answer is yes. Conditional yes. You know, I haven't gone around and knocked on every airline's door to see what they're actually doing. They are required to do actual stall recovery training. Many of them also do approach stall training, which is different. If you don't actually stall it, you don't need a pullback, or you don't even have to push over. You just control the airplane like it's slow. You know, you're just trying to control the airplane. What the FAA has actually said is they want the stall recognition and recovery training to be primarily a demonstration. So we want the instructors in the simulator to walk you through this procedure, recognizing what you see, watching the airplane go over, watch it do this, and then talk about 1, 2, 3, how do you get out of it. So it's training, not checking.
Yeah, Roger, I know there's been a little cottage industry that's grown up in the past couple of years for upset recovery training, taking airline pilots out and kid specials and teaching them that stuff. Are you seeing airlines actually doing that, or is that something they're embracing, or is it just a couple guys with kid specials trying to find a reason to make money?
And they caught, the guys online heard your question. You asked if airlines are actually taking pilots out of the kid specials and other kinds of airplanes and doing off-site type of upset training. That's never going to go anyplace. I mean, there's nothing wrong with doing it if you want to do it, like fine. But it's a massive expense, and it's not something the airlines are going to do. And it's a different kind of airplane, different aerodynamics than the airplane you're actually flying. Yes, you know, when it stalls, it's supposed to pitch forward. That's about all you really have in common. So I would say it's up to the airlines to do the training properly for their pilots. And that's why we want the simulators working properly. We want the instructors to be properly trained so that they teach you the right things. Because otherwise, you could get what we call negative training, teaching you the wrong things. Anyone else?
Let me see, we've got some questions online.
Okay.
I'm sorry I came in the middle of your discussion, sir, but one of the things I thought that came out of that mishap was crew rest requirements and things like that. Didn't they also, coming out of that mishap, wasn't it the same push that created a 65 retirement or 60 retirement, all that sort of stuff?
Yeah, well, we've got a concatenation of things that you're kind of all pulled together in one, and it's really different things. Your question was, did the major fatigue changes to the regulations of airlines come about as a result of this accident? And the answer is, it was kind of a coincidence. So I said this was the culmination of many previous accidents, previous cases, and the fatigue pot had been boiling for a very long time. So yes, we brought up commuter fatigue in this accident, but the FAA at that time also came out with Part 117, which was a complete rewrite of fatigue rules for passenger airline pilots, and it's much more stringent. But it was going to probably happen anyway. This is when I talk about a catalyst in my first slide there. Sometimes you need to get a major attention getter like this accident to light the fire under the FAA and get stuff moving. So the answer is sort of. Sure.
I'm sure you mentioned it and or is implied, but I just want to make sure I'm correct with the pilot of that aircraft never stalled that aircraft, actually controlling it or in simulator. He's never actually felt a stall in that aircraft. Is that correct?
And so your question was, the pilot of this airplane had never stalled this airplane?
Well, on purpose, in training.
On purpose, on training? No, and neither had any other Colgan pilots or any other airline pilots. It simply wasn't done. Yeah. I'm talking about a real stall. I'm not talking about everybody that approaches the stall.
Right.
So when it comes on, okay.
So the FAA at that point is teaching stall avoidance, not stall recovery. Or the airline.
That's right. And many people, including a lot of people in the manufacturers, particularly Airbus, thought that was just fine. And why rock the boat? A lot of people in the industry, including Airbus and manufacturers, and FAA, and a lot of people kind of put the blindfolds on. They didn't look at the fact that this wasn't just a one-time problem with one airplane and one crew. It's a big mistake to just say, well, this pilot was a screw up before, the rest of us are fine. This was a system failure. All of the training was wrong. All of the simulators were wrong. A lot of what we were teaching was wrong. And getting people to admit that is not easy.
One thing I saw in my military time was that there are certain airplanes that stall really well and spin really well. The T2 is the classic one on the Navy side. You can take that thing up to 25,000 feet, give the controls to a navigator like me. I put it into an air, and I was allowed to do this. The pilot up front, I'd be the back seat. Put the airplane into this big departure, let go of the controls. No matter what we do, the nose would grab the ground and it would fly itself out. But there are people that have grown up in airplanes that stalling them or spinning them is the very idea is perfect. And if you've never been in an airplane where you realize that, okay, maybe in this particular airplane we can do that. So in small airplanes that we fly, we teach stalls to accept into design. Those kind of airplanes are not. But there's got to be some middle ground saying, how do you train a guy to get out of a stall that he might get into? But the very idea of going into a stall is terrifying. How can we possibly train it? It's not terrifying. It depends on the airplane.
Great, that's a great point. I flew this particular airplane in a simulator at Flight Safety, and I duplicated the conditions of the airplane. I slowed it up, and we got it to stall. And all you really had to do was just unload it. I mean, you didn't let go, but you could give it a little nudge, and it would come back down and start flying. It was a big straight wing. I mean, it was a very stable airplane. It was never any reason to stall an airplane like this. You really have to try to stall an airplane like this. And on my experience, T-37s were great airplanes to stall. T-38 got into that supersonic trainer. We never stole those things new, because once you got it into a spin, you couldn't get it out. Very, very unlikely. You got a drag chute test pilot, you might be able to, for the most part, punch out.
EA-6B, F-14, you didn't go there. But the point is that you got to fly the T2 and the T-37, and the idea of stall was not an idea to make so dangerous I can't even attempt to practice it in play. Here's a good technical question from Jake from Jimmy Holly. Do you think the high aspect ratio of the wings contributed to the inability to regain control and did weight and balance play any factor?
Well, those are good questions, and the answer is no. This is a highly did weight and balance or CG or aspect ratio have anything to do with the ability to recover the flight? The answer is no. This is a highly controllable, stable airplane. It's very flyable. It's just as I described when I flew the simulator. And center of gravity could be a factor, but it was not in this case.
Is anybody else out in anybody else here have a question?
Yeah.
Even though you got a stitch shaker, I mean, at what point in training do they teach you, I mean, to get out of, obviously there's stitch shakers, to nose over.
It doesn't, it's not instinctual. Pushing the nose over is a very unintuitive kind of thing to do. It's something that has to be done through your cognitive processes. You have to recognize it and do something that isn't natural. The most natural thing in the world is to pull back. We do it all the time. That when we're trying to control an airplane, and it's a little bit out of trim, the nose tends to drop a little bit. What do? We pull back. The nose is coming down, we pull back. So that's the instinctive thing to do. So with regard to your question, which was how was training being done at airlines when you've got a stick shift? The training was what we call approach stall. What you do is the minute you get the stall warning, you go through a recovery procedure. You apply power, you accelerate, you maintain level flight. As you accelerate, you track the gear and the flaps, and you fly away. And that was taught over and over again at airlines, which is fine unless you go over your actual stalling angle with that. And then all bets are off. Your plane behaves completely differently, and you have to recognize that. Too many times, both in GA and in the airplanes, pilots miss it. They don't recognize it. They don't realize they've stalled the airplane. And so they never have that cognitive leap that says, oh, wait a minute, I'm not in a normal regime of flight anymore. I'm in a stall. I'm out of control. Now what do? And switch gears, nose down, unload the airplane. Even when you're upside down, like that picture I showed you, 737 simulator, even if you're upside down and the ground's coming up, you have to unload the airplane. Unload. Release that push. Unload the wing, because the wing doesn't care if it's right side up or left side down. Okay. The tendency might be to pull back. I see the earth coming up, I want to pull back. Unload the airplane and then roll to the horizon. Recover airspeed. But wait a second, you're stalled as you recover. And in a big airplane, that takes a lot of altitude.
I mean, listen, if you think about an airplane specific thing here, you're thinking about how all the training we do in stalls and well-behaved airplanes like first of all, you know you're going into it, so you're ready. Okay? But when the airplane stalls and the nose drops, what you're trained to do until it's a reflex is power on, start moving the flaps up in some sort of sequence. If you didn't know that, your natural instinct as the nose starts to go down is to pull back. So what we've had to do in training is condition you to do that response. And I think that's kind of what we're talking about, the cognitive loop.
Yeah.
Until it actually becomes a condition, a reflex. But if you haven't been trained to that, it's not obvious for moving the airplane around. The thing to do when you're going down to the earth is to push the nose forward, because you know that I can stay away back. But you're going down to the earth, let's push the nose forward and look further down. So you've got to train that in. And if they're not getting conditions, if they're not actually doing that in the simulator, then that loop isn't there. Is that a fair statement?
That's exactly right. You're good at what you do a lot of. But if you mislead yourself into thinking you're going to be good at something you don't do, when you're confronted with it, you're surprised that you don't react properly. So that's the goal of training, should be to identify those critical skills that you need even when you hardly react to do something.
Roger, there's also another question from Boone asking about sterile cockpit procedures.
Yeah, that was a big deal. I just touched on it because we said professionalism was an issue. I talked about it in class. We did a forum on it. We called a whole bunch of people across the airline business and talk about what is professionalism. We could talk for an hour on that subject. This crew, unfortunately, was not very professional. They were engaged in a lot of personal conversation. In this checklist, they were late in conducting their descent approach checklist. And they were just behind the airplane because they weren't paying attention. So that's a big part of professionalism, is knowing, when to run your mouth and shut up. When do we need to do this? It's embarrassing to listen to this. The CDR, because of the conversation that's going on. And the two of them. So when we talk about professional behavior, we're talking about other things. We're talking about cell phones. We wrote a recommendation that you mentioned, right, about personal electronic devices, PEDs, is what we call it, for your cell phone, and restrictions. The board wanted to see those absolutely not used on airliners. Now, you know, and I know that they are. They're a really handy tool. There are times when they're actually the best way to get a hold of somebody when you need something, particularly if you're on the ground in Yuma, you know, and you need some fuel or something like that. Cool. Phone you call. But they're easy to misuse, and now we have a lot of iPads in airplanes for legitimate purposes, and it's an even bigger challenge. You know, we don't need you talking to, you know, your significant other about picking up the groceries on the home. Flying an airplane.
I'll chime in on that. When I took my flight instructor refresher training a couple of months ago, the instructor told the story to third hand, that I believe it, about, I think it was at a regional, where there was a pilot and a younger co-pilot, and they taxi out, and the pilot's over, and the younger co-pilot is texting while they're taxiing. And the pilot, the captain, goes kind of ballistic on it, put that thing away. Guys said, Roger that. And then 3 minutes, 4 minutes later, he's doing it again. And the captain stopped, turned the airplane around, went back to the gate, and called dispatch and said, we need a new co-pilot. And then when he talked to the chief of ops of the airline, the chief of ops said, well, you're a check airman, right? And yeah, so you can basically fail him on any flight. Yeah, and they fired the guy. So it should be obvious, I hope, that, you know, texting while taxiing, yeah, don't even think about it. And those of you that have been in my classes know that this is a soapbox with me, because those of you that can't see me, I'm holding on my cell phone. The people who make these things and who make Facebook and all this other stuff kind of design it to be addictive. So it's our job to not fall into that addiction. Sometimes we just got to put it away. You know, as Roger said, the iPads are really useful, but my iPad, I only use it for foreplay. I don't use it for anything else, because I don't want to be conditioned to be checking my email on the same device that I'm using in the airplane.
So when we had our professionals, we had a really bunch of great people, but one guy in particular came from Compass Airlines and gave us his rundown on the attributes of professionalism. And he talked about all the things we can train. Train you on the airplane, and train you about leadership, train you about many elements of responsibility. You can train almost everything, but there's a couple of things we cannot train. One is maturity, and one is emotional stability. Another one that's kind of a maybe is your attitude towards your appearance, your attitude towards how you come across to other people. These are things that should get you out at an airline. Today, we have an unprecedented opportunity for all of you to get jobs if you want, unlike anything I've ever seen. These measures that we put out as a result of Colgan are designed to address these problems, so that when we get you into the left or right seat of an airliner, you've got not only the skills, but you've got the attitudes, the willingness to follow SOPs and to comply with the rules and operate professionally.
All right, I think we're complete on this one. And folks, normally we do an AOPA video between the briefs. I'm going to skip that this time. But first off, before we do anything, let's take a big hand for Professor Cox today. I continue to be happily amazed at the quality of briefers that we've got at this at these events. Thanks again, Roger. And on that note, we've got J.B. Hollier coming here in a minute. He's going to talk about he's going to tell us an interesting story about a flight that he went on. And I had the good fortune to learn from his less than good fortune at a different venue a few months ago. So I asked JB to come back. However, I think we all need a break. So let's take 10 minutes. I'm going to put the recording on pause, And I'm showing on my cell phone right now, it is 11:50. Let's be back at 12 noon sharp, and we'll kick things off again. So wherever you are, take a stretch, and we'll be kicking off here again at 10 now.
This meeting is being recorded.
I can just up and down on the slide, right? Or space bar, okay.
Okay, folks, we're back. Welcome back. And as I said, we're fortunate today to have some serious rock stars on our stage. And act number 2, J.B. Hollier, retired Navy captain, test pilot. Probably more airplanes than we have fingers and toes that you've flown, I'm sure. About 6,000 hours.
6,000 hours.
So JB's going to tell us about an occurrence that he had flying a classic airplane. I guess it was about a year and a half ago now.
Actually, it was August 25th of 18, so
Okay.
not quite a year.
So JB, you got it.
Are you guys all in training to be pilots?
Oh, and sorry, we're going to need the microphone.
Okay. Oh,
Yeah,
all right.
Otherwise, they really can't hear us.
Okay.
And just make sure you hold it like that.
Okay, till I hear myself.
Make a noise.
There you go.
All right, if I get too loud, let me know, sorry. So all you guys are training to be pilots, right? Desire to be airline pilots? Sort of, maybe. I've never been an airline pilot, to be honest with you. I did 24 years in the Navy, most of them in flight desk. I have very few hours in an aircraft, over about 4 or 5 hours at a time, and at this point, I got about a 2-hour butt, so I can sit in an airplane for about 2 hours, and then we got to land and go someplace and take a walk. So this is a little story about an aircraft that I bought a number of years ago.
Excuse me, JB. I think they're telling me that
Too loud?
I think you can actually hear better without the mic.
Okay.
Is that correct, guys? Ditch the handheld. Okay.
Got it.
All right.
Is that good for them? That's
Yep.
better for me.
It's working for them.
Terrific. So a number of years ago, I retired from the Navy about 14 years ago. After 25 years in the air, I actually did 22 out of 25 years flying airplanes. And I missed aviation so bad, I had to do something. So I bought an old North American Navion out of a barn in Austin, Texas, and tore it all down and rebuilt it with a close friend of mine that was an AMP mechanic, and fell in love with that airplane. And then a little while later, I got to fly in with some airline friends of mine, and they had an Albatross, and I got to go fly the HU-16. When I was in flight test, I'd flown it for one sortie, a couple of water landings, and I flew the PBY Catalina, and I fell in love with the Catalina. And when I got to the point where I could actually afford to go buy airplanes and all my kids are out of college, I realized I couldn't afford a Catalina, but it turns out I could afford an Albatross. So I convinced my wife that this was something that she wanted to do too, and that worked out really well. And then we spent about a year looking at, I think I looked at every Albatross in America, really. And they're out there. That's one. That's a long winger. She needs a little love. Another one, this one's in Okmulgee, Oklahoma, needs a little more love. But these are complete airplanes that you can go find on the ramp. Katanga got a hangar dropped on her down in Miami. She's still out there. Same one down in South Carolina. This one is actually a reasonable airplane from the outside, but when you dig down inside and take a look, you start finding some of the corrosion issues that are incidental with the airplane. That's a beauty. She's out of Carson City. Short wing Albatross. There's basically two kinds. There's a short wing and a long wing, and then there's sort of two kinds of a long wing. The long wingers that the military used, and then there were about 15 that were part of Cox Airlines that were bought out of the Air Force, and Grumman converted them into commercial airliners. They're called the G111. That's a G111. That was actually owned by Cox Airlines at one point, actually owned by Billabong in this picture. And I helped ferry that aircraft out of Florida. That's what I was talking about with finding corrosion. For those of you who have been mechanics or done any kind of work on an airplane, when you start taking flashlights and going way back and looking at spark caps and you see that stuff, it gets a little scary. So you have to keep looking until you find the right airplane. And eventually you find her, right? This was down in Conroe, Texas. And I said we'd looked for about a year, and I'd all but given up finding the right airplane. These guys had two. They had her and another one, and they liked the other one better than this one. So it had sat there for 5 years, hadn't so much as turned engines. So I started working with them and talking to them, and what's going on? Why haven't you flown the airplane? Oh, it's just, it needs some work, and we don't have time. And we'll come to find out the whole airplane was wired wrong. Somebody had made a mod to it. They'd put alternators on the engines instead of generators, trying to save a little bit of weight. The alternators were turning at the wrong speed for the gearbox in the engine, so they kept burning out their voltage regulators. Anyway, we flew the airplane home on a ferry permit, which is kind of a permission to fly an airplane that hasn't really been checked out completely, but we know it's safe to fly. We had a turn needle in the cockpit. We had sets of batteries in the back of the aircraft, and we would wire them up in parallel. Parallel gets you 212s is 24, right? So you wire them in parallel, and then when the batteries get so low that they're not really holding much anymore, you got to be above about 20 volts to make everything really work in the aircraft. You'd switch over to the next set of batteries, and you put those on charge. So we managed to fly her from Texas up to just outside of Washington, D.C., St. Mary's County Airport. And she needed lots of love, but I got to introduce her to my wife. She actually liked it. We had a lot of fun with it. We did a lot of flying with her, got her all cleaned up, started doing fun things with her. So what do you do with an airplane like that? Well, you go to air shows. That was the Pax River Air Show. They don't get out very often. The Albatrosses, there's probably a dozen of them that fly regularly in the U.S. There's probably another dozen, maybe 15, 16 that can but don't for whatever reason. They're hangar queens. People polish them a lot but never get out and fly them. And and a couple that are on popsicle sticks here and there around various military bases and in museums, and the rest of them are all rotting away like those first few pictures I showed you. So we did air shows. We had a lot of fun with her. This was the Udvar-Hazy Air and Space Center. They invited us up, put us at Air Show Center. That was just an unbelievable weekend for us. We'll talk to that a little bit later. We took it to the Triple Tree Fly-In. For any of you ever been to SC00 down in South Carolina, that is a wonderful, wonderful show to go to. It's just a fly-in, so you'll see all kinds of stuff. Antiques, warbirds, every kind of airplane you could possibly imagine. A lot of fun we had there. Went to the Culpepper Air Show, lost the big fight with the FAA. Pegasus was a restricted category aircraft. And when you get to the point where you're playing with airplanes and you're trying to understand standard airworthiness categories versus special, and then inside of special, there's restricted and experimental. There's a whole bunch of rules that make absolutely no sense to anybody except some clown at the FAA. And if I'm offending anybody, don't, but
He said CSB.
okay, good, good. So one of the things we were allowed to do in a restricted category was aerial advertising. And there's a bunch of different pieces you can do. You can do aerial advertising, you can do crop spraying, you can do cloud seeding, there's a whole bunch of different pieces you can do, but they all have to be on your ticket to do it. Aerial advertising was on our restricted ticket. We were part of an organization at the time called Seaplane Crossings, which is, we'll talk to in just a second. But so we had a big Seaplane Crossing sticker on the front of the airplane that we'd spent huge dollars to put on there for them so we could advertise. And the guy at the FAA said, well, you can't fly in this air show. You're not an experimental category airplane cleared for aerial demonstration, I think is what they use for experimental. I said, no, we're not. We're restricted. Here's my ticket. And aerial advertising is authorized. FAA guy said, well, aerial advertising is towing banners. I said, no, that's banner towing. Aerial advertising is aerial advertising. And there's a bunch of different ways to do it. And amongst them is I could put a speaker and hang a speaker outside the airplane and yell real loud. And that's aerial advertising. A whole bunch of different things. He didn't agree, so he shut us down, wouldn't let us fly in the air show. So they ended the air show 2 hours early so that we could go fly. You'll see the T6 in front of us out there. So we took off behind the T6s and joined up and had a great air show after the air show because we had to be after the air show. So there's ways around the FAA. You just got to work your way through them. They're not really there to help. I think their motto is, we're not happy till you're not happy. So it works pretty well. You just got to, work your way through it. The other thing you had to do was a lot of maintenance, right? I mean, Standard oil consumption, these are R1820 radial engines built by Wright, 9-cylinder. On a good day, you burn about a gallon of oil an hour on one of those things. The spec for them is about 0.6 gallons an hour. My Wright engine, when we finally said you're done, was burning about 3.5 an hour. It's okay, you got a 32-gallon oil tank, so you could, keep filling it up. But at $20 a gallon, it gets pretty painful pretty quickly. So we finally sent that out, and way too much money later, we finally got her back. And that engine burned about a pint an hour after that. So you can clean them up, you can tighten them up, and they'll do really, really well. But you got to stay ahead of the maintenance and keep doing it.
JB,
Prop changes?
can I just point out that
Sure.
what you just said, you had a 32-gallon oil tank and you kept burning through it. So these
Correct.
airplanes are using oil at the rate that our airplanes are using gas.
Pretty close. In fact, during the Korean War and stuff, they used to fly these across the Pacific. They put 55-gallon drums of oil inside the aircraft, and you'd pump it to keep that oil tank full with a 32-gallon oil tank. It was just the way they were designed. They leak a little bit. They're making full compression. They're doing everything they're supposed to do, but they just start, wearing down. So you can spend the money and bring them back, which is what we started doing with her. Working firewall forward on Pegasus, new props or rebuilt props. They don't make them anymore, so had to work that. But you just keep working your way through it. And then you start to really go play. Because now I got an airplane that'll do dang near anything. So we did a aerial review with Liz Walters. She flew out in another aircraft and took aerial photographs of us. These are just some of the things we had fun doing. We went, again, more air shows. That's how to keep your wife happy when you're out with your girlfriend. Have her putting guys in the girlfriend. It works out really good. Playing on the water on Lake Gaston. We put this thing on the water every opportunity we had. We hopped from Washington, D.C. down to Texas, hit every single lake that was big enough to land in, all the way to Houston, Texas, and all the way back again. We took her offshore. We landed offshore. We took her every place we could possibly go and fly on the water because that was what she was designed to do. That's on the water in Conroe. This is having a lot of fun in Conroe. We decided we were going to have what we called the gaggle of Grummans. So we started inviting albatrosses down to Conroe. The beautiful thing about Conroe Airport is as you climb out on a south takeoff, with a right turnout, you're on a left downwind for Lake Conroe, which is about 30,000 acres, 28,000 acres. Giant lake. Had a lot of fun. That's Connie Edwards. If anybody here wants to talk Connie Edwards stories, I'd love to do that afterwards. He's an absolute legend. That's his favorite airplane of the airplanes that he owns. He bought that off the Commandant of the Coast Guard. The day it went into the desert, he bought it back out. This is, again, more fun. Going out and having fun. In fact, the silver airplane in the back is the other airplane that the guys had when I bought Pegasus. That one made the cover of Seaplane Pilots Association magazine. They had a Big Bird calendar that year. We'd sent some pictures in. They chose that one. And we did a lot of celebrating. Every time we flew check rides, it's over 12.5, so you got to have a type rating. Again, going back to the FAA regulations, you're not allowed to train in a restricted category aircraft. You're not allowed to do any kind of training in it. So we weren't really sure exactly how we actually could fly our training flights and then get check rides in the aircraft. We wound up just not really listening a lot to the FAA and doing what we needed to do. You need me to stop?
Actually, just keep talking. Please don't object to the pizzas that are coming through.
Sure.
Oh, gentlemen,
Oh, gracious.
ladies, pay attention to JB.
Look at that.
So let's pay attention to our speaker who's done a great show to come here, but very quietly grab some pizza for me.
Sure. So this is Team Pegasus. These are the guys that I flew with, right? As I mentioned, I was a Navy test pilot for too many years, too many hours, and too many different make models. The guy in the center is our chief mechanic, probably the best mechanic I've ever worked with in my entire life, bar none. He worked on my aircraft when I was a skipper of one of the test squadrons. And the guy on the right is an Air Force test pilot, F-15 guy, 2 kills in the Gulf War, taught at Navy Test Pilot School as an instructor pilot. He was my co-pilot for everything that we ever did on this airplane. So then, going back to the hurricanes and what's going on in the Caribbean. The 2 back-to-back hurricanes that went through the Caribbean back in the summer of 17, St. Thomas got crushed twice in a row, 2 weeks apart. They had absolutely nothing going on in St. Thomas. This was another one of those situations where you go bump up against the FAA and the FAA says, well, you can't carry cargo. I have cargo on my ticket. You can't carry cargo in your aircraft. Okay. Well, cargo for hire, somebody has to pay me to do it. So if I volunteer, no problem. I can carry it for free, right? So that's what we did. So we flew 3 round trips into the Caribbean to St. Thomas in their 2,400 miles round trip, 1,200 from Fort Pierce into St. Thomas, and then back. 82 hours and 11 days on her, and carried almost 13,000 pounds of cargo. It was just astonishing. We just loaded the back end of that old girl, kept our weight and balance, created our own software program to do all the math, and flew it in. Slam Duncan, if anybody's a basketball fan, he's from St. Croix. We were delivering to St. Thomas. When we left to go to St. Thomas, we had no communications into St. Thomas. The Navy had closed off Puerto Rico and was using Navy air traffic controllers to control airspace. The tower had been blown down in St. Thomas. We had no idea whether they had any fuel. We hadn't been able to talk to anybody, but these guys had nothing. So we put 5,000 pounds of crap in the back of the airplane and launched out of Fort Pierce, got outside the 5-mile limit or 10 miles or whatever the airport traffic area is down there, turned off our radios and didn't talk to anybody for the next 1,200 miles, never got above 1,000 feet and all the way to St. Thomas, rolled final in St. Thomas, no tower, no communications. We're calling on tower frequency. There's another guy coming in from Puerto Rico, an Air Force aircraft carrying supplies. And we're like, okay, so who you talking to? And he goes, you. We're just using it like a Unicom. Okay, great. So you adapt, you overcome. And we used a Unicom down there for the next batch of trips that we flew in. That was quite the experience. I got to tell you, we really enjoyed the hell out of that event. So what do you do after that? What's the next thing? Well, we decided we're going to go replicate history. We're going to become part of history. The 100th anniversary of the first crossing of the Atlantic starts in 7 days from right now, the 8th or the 9th or whatever it is of May. NC-4, the Navy Curtiss NC-4 started its transatlantic flight, flying up the coast. This is the route of flight that they took. So we said, 100th anniversary, by God, let's do that. Let's be the 100th anniversary recreation of that crossing. So we worked on it. We created Seaplane Crossings. It's a nonprofit. Started working on it. We worked with the James Forrest Tech Center down in Pax River. That's a terrific organization. They do a lot of great stuff with kids. Teach them how to be aircraft mechanics. They teach them how to do electrical work on airplanes. And part of our world was trying to involve all the kids in actually touching the metal and doing fun stuff. So they came out to the aircraft. They helped us do maintenance on the aircraft. They worked on our tug that we used to push the airplane around. They overhauled our electrical power carts. It was a terrific relationship with those kids at the school. They designed that thing for us right there. What do you call that? Poster right there for us. They did a wonderful job. We decided we're going to exactly duplicate the route. We tried to go with 3 airplanes. They started with 3 airplanes, NC-1, NC-3, and NC-4. 1 and 3 wound up landing and damaging the aircraft en route. They got lost en route. Long story, not really worth going into on this discussion. But we're going to fly the exact same route. The difference being we're going to start in Pensacola and try to focus a little bit on naval aviation since we were naval aviators and it was a Navy airplane. Stop at the Udvar-Hazy Center because they wanted us to. We were going to come into there, work with them for a while, and then on up to New York and leave out of New York Harbor on the 8th. This was our route of flight. That's what we were doing. And then we had that pretty much suitcased and ready to go when we lost the aircraft at sea. Trying to figure out what you do with an aircraft that's like that is all the group that worked with us believed in flying airplanes the way airplanes were designed to fly. Go back to the whole discussion on an aircraft. An airliner lives in an envelope that's this big, but the airplane has an envelope that's this big. And so as test pilots, we'd spent our life defining envelopes. You define the low end of an envelope. You define the high end of an envelope. You go out and you work with airplanes to try and figure out what does that thing look like. And so we believed, rightfully so, in my view, that that airplane was designed to be on the water. So we spent every opportunity that we had being on the water. That was a search and rescue aircraft for the services. It was cleared in 20-foot seas. It used JATO for takeoff. It was an amazing machine. So we said, let's go look and see what else we can do with an airplane that's like that. And we had been working with the Navy on a project doing some water sampling. And they had these fancy buoys that they were using. And they came to us and said, hey, can you guys put these buoys in the water? We pay a ship $25,000 a day to drive out there at 20 knots or 12 knots. Takes them 4 days to get out there. They spend a day putting buoys in and 4 days to get back. It cost us $250,000 to put 4 buoys in the water. And we're like, we'll do it for less. I don't know what, but we're going to go figure it out. We're going to do it for less. And so we did. We developed an entire plan to go do surveillance of the Gulf Stream and the eddies around the Gulf Stream for these scientists. The first event was 400 miles offshore in the Sargasso Sea. If anybody's spent any time flying over the mid-Atlantic or southern Atlantic, you've seen the Sargasso out there. It covers hundreds of square miles of ocean. Sometimes it's so thick that you don't see the blue, you just see the brown.
It's the Sargasso's got this floating seaweed in it.
It's floating. Sargasso weed is what's in the Sargasso Sea. So what they wanted us to do was go out, fly up along the Gulf Stream, cross over. If there was an eddy on the side of the Gulf Stream going this way, they wanted us to put a buoy dead center of that. Take off, find an eddy going this way, put a buoy dead center of that. Find null spots and things like that. But place 4 or 5 of these buoys for them. We said, sure, we can do that. The buoy is the EM Apex buoy. It goes up and down. It'll go up and down about 1,000 meters, 1,500 meters at a time. We set them to go up and down 300 meters. They weigh about 65 pounds each, pretty easy to move around inside an airplane. A little over 5 feet tall. They're about 12¼ inches in diameter, and they'll stay out there for months and months and months, and then you can go pick them back up again. We're going to launch a wave rider, which is a round buoy, kind of a spherical thing. And it just floats on the surface and is influenced by the water, motion, waves, and wind. It also lasts for months and months and months. Being test pilots, we said, okay, well, we need to work this up. We need to go figure out how we're going to go do all this. And then what do we have to go fly oceanic, right? This airplane has been landlocked in America for since 1962 or whenever the heck it went to the desert. So we started backing up and using, I was a P3 guy in the fleet. I'd spent a lot of time over the water doing different things. We went and hired ourselves an ex-P3 navigator, communications guy. We added an HF radio to the aircraft. We added a VHF Marine Band aircraft radio to the aircraft. We started upgrading all of the avionics in the aircraft, went to WAS on our GPS. We had a fairly updated modern cockpit anyway, but we updated it to the best of our ability at that point. We added, going back to the whole discussion on Alpha, we added the Grumman Alpha gauges to the aircraft in case something happened and we had to land at night. And then we started grooming the airplane so that every event we flew was about 12 hours so that we'd see the different things that were going on with the aircraft and repair them and do them and get things moving. Then we went out and got currency. We went out and flew the aircraft. We flew it on the water at lakes around the country. We flew it in the Chesapeake Bay as the seas got more and more and more. And then we finally took it 25 miles offshore and started doing landings and building up to a sea state of 3. And for those of you who haven't seen a sea state of 3, the waves are about that high, somewhere around 4 or 5 feet, and the wind is blowing the top of the wave off. You're starting to get sea spray off the top of a wave. So the winds are in the vicinity of 15 knots. And as I mentioned, the airplane was cleared to do 20-foot seas with JATO. A lot of the guys you talk to are all 12-foot seas, no problem whatsoever. So then we built a test plan, and we went out and tested dropping the buoys in the water and picking the buoys back up again, come back around and land, find them from the air, and then pick them back up and do it. We had a buoy finder that we had developed with Johns Hopkins University that would track us into a buoy. That worked pretty bad. Luckily it gave out lat longs, and we could plug a lat long into our GPS and still go find it. So that worked out pretty good. And we just practiced. It's exactly what he was saying. If you don't practice it, you don't know how to do it. So we went out and practiced until we were very, very comfortable. Then we defined everything for the mission to be less than what we'd practiced. We went out to a sea state of 3. We had to have less than a sea state of 3. We had to have no white caps. We had to have winds below 10 knots. Or 15 knots. We had to be in VMC conditions. We defined this whole thing all out there. And then we did our best to determine what the seas were out there. We had buoys within about 200 miles of where we were actually going to land, but it was pilot's call. We got the group that we were flying with. If this thing says it's a sea state of 1 and we go out there and we're not comfortable, we're coming home. It's that simple, right? I mean, we got too much invested in the aircraft. We did it as a minimum crew event. We had our mechanic with us in case we had problems. We had our open ocean nav. We had our 2 pilots, and we had a Navy oceanographer. That was all we took with us. We put together a full comm plan. We had, of course, HF comms. We had a shore watch based at Johns Hopkins University that we talked to continuously. We had 2 Iridium cell phones, and we talked to them, kept them charged, talked to them every 15 or 20 minutes outbound. That was kind of our lifeline to things. And we also had a little device called a SpotX. If nobody's ever heard of it, it's really cool. It lets you do texting via satellite, via Iridium satellite. The cool thing about Iridium is it works in the middle of the Atlantic Ocean. You don't have to have a cell tower. So it's really nice to have something like that. We brought spare parts with us. We, had done maintenance on the water before, but we've never changed a jug or anything like that. But we had our mechanic. We brought our spare parts. We knew what we needed to have. We brought tools with us. And the most important thing we did was a risk hazard analysis, where we went and we got a couple of smart guys and we all sat down in a room and we argued and talked. And what about this? What if a meteor takes your wing off in the landing pattern? You work our way through all these possibilities, and we came up with these identified risks, okay? These are the 8 risks that we work to mitigate completely, right? Now you'll notice that risk number 2 is aircraft cannot take off from the water. Our brains at that time were not thinking anything except, we landed, we shut it down, wouldn't restart. Or we're halfway home and the prop oversped and we had to land on the water and now I can't take off again, right? We never conceived of having a problem on the water that was anything other than a mechanical problem. And we mitigated those problems that you'll see as we go. Here's an example of how you do something, right? Airplane experiences an airborne emergency of some sort. So you define the risk. And then how do I mitigate that risk? Well, I've got experienced flight crews. I've got the flight manuals on the aircraft. I can land pretty much anywhere. I got 400 miles of runway in front of me. So you work your way through all the different pieces. Well, this is risk number 2. An engine does not start on the water or the aircraft cannot take off for any reason, right? All right, so let's mitigate that. Let's not turn our engines off on the water. Let's make sure we got extra set of batteries in case there's a battery problem and we need to, run. Let's make sure we got a starter, an extra starter. Make sure we got a mechanic to change the starter. But you look at the risk cube and the only thing you see that's not green is risk number 2. I can't get off the water. And the reason is because if I can't get off the water, I've got this amount of time. I don't know what that is. It really depends on the weather that's coming. I got this amount of time to get that airplane out of there. I can call a sea tow. I can flag down a ship that'll pick me up and put me on the, fantail of the ship, whatever. I got that amount of time to get that airplane out of there. Well, some of the other things we talked about, the buoys and problems with buoys. What if somebody fell in the water? We had 2 life rafts with us. We had full buoyancy compensation devices for everybody. In fact, we had 2 for everybody. Kayak for sending somebody out to pick somebody up, to grab a buoy if we needed to, whatever the pieces were. We can station keep, the propellers go into reverse. You can do pretty much anything you need to do if everything's working. So despite all of the planning, despite having, pilots with thousands of hours of flight time, hundreds of hours in model, that had flown over the water, that had landed on every lake in America and offshore on the East Coast, the worst things in the world still happen. You can't escape some things, but the best you can do is always plan for contingencies, right? So we took off that morning on the 25th. That was a Saturday morning. We flew down to Elizabeth City the night prior. We'd been watching buoys out there. The seas were all coming down. They were down below 3 feet. They had been up about 16 feet in previous days. We were watching the buoys. So we were watching, they're coming down. We're looking at the weather. Okay, time to go. So we flew into Elizabeth City. We launched out the next morning at 8 a.m., wheels in the well. Flew 400 miles out to our first buoy placement, which was at 70 West, 31 North, right dead nuts in the center of an eddy off the eastern side of the Gulf Stream. About 15 miles from on station, we passed this giant freighter, the MV Polar Peru, brand spanking new, 45,000 ton freighter. And 10 minutes later, we rolled in, we tracked the winds for what we needed. We flew a 2-mile line into that buoy placement location. We flew it twice. And then on the third pass, we landed, making sure that the water was clear, taxied up to the location where we were going to put the buoy in and placed that buoy at 11:25. We were within about 100 meters of where that buoy needed to be based on our GPS. So we knew we did the right thing. So we clean up everything inside the aircraft, we get everybody back in their seats, lock down all the equipment that we'd taken out to launch the buoy, start our takeoff roll, and at 60 knots, the cockpit exploded. Right underneath the pilot's seat, a gash tore into the bottom of the hull, about 3 feet long and about 8 or 10 inches wide. The water exploded through the cockpit, knocked headsets off, wiped out all the avionics in the cockpit. The plane swerved to the left. I thought my window had broken, that something had come in the window of the aircraft and broken that window because I was soaked from here down. I didn't really understand that. My co-pilot looks over and I was looking at his eyes as I was trying to control the airplane. I'm going, what just happened? And he's looking underneath my seat and it's wide open. It's all daylight. So he calls for the abort. So at 60 knots, 10 knots prior to rotate, we aborted the takeoff. And the assessment, when you're looking at it, was this giant hole underneath the pilot's side, below the waterline. We had 16 inches, 18 inches of water inside the cockpit. The damage to the hull was in that compartment and the compartment forward of it. So those were flooding. The aircraft was starting to go nose down in the water. I had no injuries to the crew. Everybody was in good shape. I had perfect engines. They were still turning out there on the wings. The props were perfect. Everything. I had zero avionics. All of my brand new HF radio, $18,000 worth of HF radios gone. The Iridium cell phones, both of them were perfect. They were in the aft part of the aircraft. The SpotX was perfect. It was in the back of the aircraft. It had been a fairly violent event, relatively speaking, to what we were used to flying on the water. Not violent enough so that when we went to the back and checked, we had to go turn the crash locator on. So we climbed back in the back of the aircraft, went back into the hellhole and turned it on. But now, risk 2, instead of being can't take off from the water, is your airplane is sinking and you can't take off from the water. Any forward motion caused the water to come through that gash in the hull, up over the top of the step and begin filling the next compartment aft. Plane has 7 watertight compartments officially. 2 of them were hold. It can't handle the third. And the third was filling up as water splashed and came in the aircraft. So now you're in a perfectly good airplane other than a giant hole, and it's compromised and it's sinking. You can see from the water, we've still, to this day, we've tried to figure out in our minds, what did we hit? What did we do wrong? We didn't clear the area on our takeoff roll. That's what we did wrong. We should have back taxied those 2 miles and taken off in that area. Could have been a rogue wave. Could have been just, they happen randomly at sea. It's just bigger than normal. It should not have hit. We should not have had anything right there. When you're on the step in the aircraft, which is where we were, the water is 10 feet behind you. So whatever it was doing this and hit the aircraft right there. At 60 knots, it doesn't take a lot. A 5-gallon paint bucket will tear a hole right through the aircraft with no problem. So there we are, stranded and sinking, 400 miles at sea. So we activate our checklist, right? We had emergencies set up with Johns Hopkins. We called them on the radios, talked to them with our Iridium cell phones. We had no communications radio-wise other than our Iridiums and our SpotX. So we texted SpotX. SpotX notified the people that were on our list of people to notify in the event of a mishap. I won't go into how they got a hold of the wives. That was really a bad situation. But what happened was Elizabeth City launched one of their C-130s out. They come blasting out there, and they didn't know what they were going to find. Rescues 2004. They were expecting to find pieces and parts of airplanes all over the Atlantic Ocean, and there we were, perfectly together, sitting in the water. They dropped us a Marine Band radio in a little box, that little canister kind of thing, which let us talk to them. And then they went and we told them as soon as we said, hey, 15 miles to the west-southwest of us is a giant freighter. Give those guys a call, will you, and bring them over? So they did. They went and found Polar Peru. Polar Peru shut down. They turned around this 755-foot, 46,000-ton freighter mid-ocean and came back, right? Coast Guard vectored us over. This is a picture from the Coast Guard cutter sitting in the aircraft waiting while she slowly sinks away. Polar Peru finally got hold of us. They were hull up at not too much longer after Coast Guard got there. Took a Coast Guard about 2.5 hours. I think they were on station about 2:30. Polar Peru got there about 4:15, 4:30. That's the Polar Peru. Brand new ship, built in April. They got there, there you go, 4:20 in the afternoon. They were hull up on the horizon. At 1700, they had brought their boat along, their small boy alongside, loaded us, my crew of 5. They told us, dude, you each get 1 bag. So grabbed my laptop, and each of them grabbed a whatever. And, we left headsets, we left everything inside that aircraft to let it go sink. And came on board the Polar Peru. They lowered their ladder, that boarding ladder you see on the starboard side there. They lowered that down, pulled up beside that, and brought us all aboard. So by 1700, we were all safe aboard Polar Peru. Polar Peru was an amazing boat. Brand spanking new. It was German owned. It was Liberian registered. 45,000 tons, 755 feet long. The skipper was Polish. The first mate, who was just the funniest guy you've ever met in your life, was Romanian. The chief engineer was Russian. And they had a crew of 22 that ran that entire ship. Germans, Filipinos, Polish, Russians, and Romanians. Not an English, American, British guy. Their common language was English, thank God. So it made you very, very humble to be picked up by 22 guys who don't know you from Adam in the middle of the Atlantic Ocean after watching your girlfriend sink. And all they could do was help us out in different ways. They were absolutely incredible. The oceanographer that we had with us, is a young female, about 27 years old, 28 years old, GS 11 or 12, admitted to us as we were riding that boat over to the Polar Peru that she's 5 weeks pregnant. We're like, okay. So we got that going for us. No medical guys on the boat. Their entire medical staff was a Filipino mess steward and the chief engineer who had taken some first aid classes. But you know what? They picked us up, said, we're going to Altamira, Mexico. We said, that's where we're going. Great. So off we went to Altamira, Mexico. They fed us dinner. We were wandering around the ship. We pretty much spent most of our time in the bridge because there wasn't a lot going on the freighter with 22 people. And about 8 o'clock, the CO walks up to us. The skipper comes up and goes, hey, who are you guys again? And what were you doing? We said, well, we're flying this project for some Navy guys putting buoys in the water for Johns Hopkins. Yeah. Well, we just got a call from the Navy via the Coast Guard, and they're sending a warship to come pick you up, Warship 87. We were like, Warship 87, so we're trying to go back through the pieces. The USS Mason. USS Mason and the Nimitz and 2 other frigates were on. Actually, they were filming Top Gun 2 off of Mayport, Florida. And the word went out that this airplane had gone down. They turned that entire battle group north to come pick us up to go see if they could save the flight crew. Talking to these guys, they cranked it up. Their max speed is 31.5 knots. So they cranked it up with the other 2 frigates they were with. They said that Nimitz passed them like they were standing still. They were 480 miles south. That went on for an hour, steaming north. And the Coast Guard called them and said, okay, we got Polar Peru. They're close. We're going to have them pick them up. Everything's good. CO of the carrier group said, okay, we're all done. Mason, go pick those kids up, bring them home. So Mason kept going. They steamed all night long, arriving at the Polar Peru as we were headed south. At 3:30 in the morning, they joined up. Of course, we haven't slept. There's no way you could sleep after a mishap like that. I'm here to tell you, I didn't sleep for a week. But they joined up with us about 3:30 in the morning. And at first light at 0600, they launched a rib. Actually, they launched 2 ribs in case one of them had a problem. They do their backup. What's that?
A boat.
Yes, I'm sorry, rib. Rigid hull inflatable boat. It's a small boy. So they launched that. They come over to the Polar Peru. They load us all up on the Polar Peru, zip us back over to the Mason. We say, thanks a lot, you guys. Polar Peru cranks it back up, keep heading for Altamira. And these guys head south. And now we're doing 31 knots headed back to Mayport, Florida. They brought us on board, complete medical, typical Navy, right? Complete medical examinations. You know, we check our teeth and make sure we've been to the dentist. They took wonderful care of us. So we got aboard that ship on Sunday morning at 6 a.m. I get my days right, days of the week, 26th. So we had spent 12 hours on board the Polar Peru. We spent 24 hours on board the USS Mason. We pull into the port. Oh, so I asked the XO. We spent a lot of time with the XO. And I said, what is it? Why did the U.S. Navy come pick us up? You know, we were safe on board. We were headed to Altamira, Mexico. I mean, none of us had passports, but we'd have survived it. You know, we'd have found somebody to hook us up. We'd have bought airline tickets home. And he looks at me like I got 3 heads. He goes, what, are you kidding? He said, you're American citizens. We're not. If it had been, you know, Joe Schmuck from Europe or something, and he was safe on board, yeah, we let him go. But American citizens, you're coming home with us. And I can't describe to you the pride you have in the U.S. Navy or the United States or something like that in a situation like that. It's hard to even let you know. Anyway, so we arrive off Mayport, Florida the next morning. The Coast Guard came back out, picked us up off the USS Mason. They, you know, took us into the Coast Guard station. We caught an Uber to Jackson International. We jumped on a Southwest Airlines flight at noon and flew home. But while we were at the airport, we had a couple hours to kill. So we sat down and had, you know, kind of this meal with the 5 of us to have a beer and talk about what had just happened in the last 48 hours and how do we feel about all those pieces, right? So, you know, I mean, this is the list. I can't even talk my way through it, okay? But it's an extremely humbling experience to have 22 people and a gigantic vessel stop mid-ocean and come back and pick you up, delaying their own deliveries, to have the U.S. Navy send a warship to come pick you up, all because you lost your airplane doing something that was fun. You were out having fun, and you lost your airplane. But the bottom line, I was very proud of humanity. I was proud of the United States, proud of the Navy, and very, very proud of my flight crew. We had lost an aircraft, but every single person did exactly what they were supposed to do. And all the pieces we were supposed to execute worked perfectly. So it's not even, you know, it's not conceivable in my mind to have actually had that happen. And I got to tell you, I was in denial of having lost that aircraft for weeks. I was like, it's not supposed to happen. I had 2 military test pilots, for God's sakes. We had thousands of hours in airplanes. We had hundreds of hours in that aircraft. Hundreds of water landings, at sea landings. We'd done a full test plan. We'd done data collection plans. We'd done a build-up process. We'd been at sea. We'd done all these things. We did a full risk mitigation. How did we get to this situation? That's not supposed to happen. So then you start playing what if with yourself. Well, you know, thank God my flight crew's safe. That's great. And oh my God, I lost my airplane, you know. So of course, in the water, we immediately launched all the rest of the buoys, so we at least completed our mission. We got that part done. But what do we do to save her? We have no way to patch a hole that big. Had we conceived of a hole that big, you know, hindsight's 20/20. I actually found a battery-powered drill that works underwater down to 25 feet. We could have brought sheet metal. We could have, you know, underwater, put a patch. What never occurred to us that failure on the water meant sinking on the water. We did not put that together. Asking yourself if you could save her. What if I'd done this? What if I'd done that? I talked to my other Albatross buddies over time. Oh, dude, it's 60 knots. You could have thrown out 30 flaps. You'd have been off the water. It would have been fine. Okay. Yeah, I probably could. I didn't brief that. I didn't brief, any explosions in the cockpit prior to rotate. We'll abort and throw flaps 30, whatever. But the shoulda, coulda, woulda, might have, all this sort of stuff is possible because you're dealing from a position of life, right? All 5 of us lived. If you'd have lost somebody, your time would have been spent going, what could I have done different? Or what could I have briefed correctly so that Don's still alive, or Richie's still alive, or heaven forbid, Katie and a baby are still alive, We did it right. We did everything in accordance with exactly the way we said we were going to go do it. And so we're dealing from a position of life, which is a really awesome place to be in. It's a great position. CIRP, the Critical Incident Response Program. Never heard of those guys. They're a great group. Another test pilot friend of mine, who's the chief test pilot out in Seattle for the FAA, my only FAA friend, I might add. But Bob Stoney, yeah. He's world's greatest pilot and the world's greatest human being. Yeah. And he's the only FAA guy I will talk to and still have a beer with. But love the guy to death. He said, dude, I'm gonna send some guys over to talk with you from CERP. And he said, it's all non-attribution, just talk to him, right? And they walk you through the what ifs, right? Because I'm just berating myself over what I could have done to save that aircraft. Well, these guys come up and go, okay, suppose you did. You put down your flaps at 30 and you did it. And you didn't make it all the way off the water and you nosed back over. What happens? In fact, you probably would have nosed back over because you had 500 friggin' gallons of seawater in the front of the aircraft and you were so far forward on CG at that point, there's no way that airplane would have come off the water. But let's say you did. Let's say you got your flaps down, you came off, and you had to put it back down. Then what happens? Well, then you'd have flipped it. No doubt in my mind. We'd have buried the nose and gone over. Okay, what if you'd have gotten it off the water and all that, well, you had held it long enough and all that water drained back out of that giant hole in the bottom of your aircraft, and halfway home, you had a prop over speed, and you had to put it back in the water. Then what happens? Now you're landing at 75 knots, not taking off. So what happens then? Well, I'd have flipped it then too, right? Because I got this gigantic gaping hole in the aircraft. Turns out that's exactly the way they used to lose the PBY Catalina. The nose doors would collapse and they'd come back and land on the water, and that gigantic drag of having that huge open thing, it would just tear the airplane apart and they would flip over. So the guy walks you through a bunch of different other types of what if scenarios that helps you put everything kind of back in perspective. I recommend them if you ever wind up in a situation where you need to do that. What did you do wrong? What did you do right? Right? I can tell you that in my thousands of reviews of that takeoff, the one thing that I did wrong, there's no doubt in my mind that I did wrong, was we landed, we taxied up to that point where we were putting the buoy in the water, and we had made 3 passes over that stretch of ocean. I knew for a fact that stretch of ocean had crap load of sargasso in it and little bits and pieces of this and that, but that path, I knew it was good. I landed on that path. I put the buoy in the water, and because my winds were lined up and the seas were lined up,
Just a little closer to that pickup.
sure. And because the seas were lined up and the waves were lined up and the wind was lined up, I kept that track and took off. I did not clear a mile ahead of me and then turn around and come back and take off over what I knew was clear water. So what did I hit? Was it a wave? Was it a 5-gallon bucket? Was it a piece of 2x4, floating around the water? I have no idea what we hit. But that's one thing I absolutely did wrong. What did we do right? Despite experience levels and all the planning, all the testing, all the buildup, everything else, we must have done something right because we all walked away from that mishap, right? So I would say there's several things. The absolute biggest thing we did right was we did exactly what we said we were going to do in the brief. We briefed that takeoff, and we did exactly what we said in that takeoff. We didn't try to ad lib at 60 knots with water flying through the cockpit and throw flaps out and do stupid crap. We did exactly what we said we were going to do. And you can get past no more what ifs, right? We planned the flight, we flew the plan. We contingency planned for every single possible thing we could think of. We missed one, obviously, not that big a deal. But when you do what you brief, you at least have an opportunity to have an outcome. And the brief for a takeoff like that, our standard brief in that airplane is, and we're using 50 inches of manifold pressure. For those of you who have flown big supercharged radials, that's a lot of juice. And there's a lot of noise in the aircraft. And you don't listen for specific words. If there's a word, that word is abort, right? You hold up numbers for power settings. You don't talk. If there's a word that comes out of somebody's mouth, that word's abort. So any malfunctions prior to airborne is what we brief. We abort. Anything after airborne, we handle it as an airborne malfunction until, aviate, navigate, communicate, et cetera, right? So this was before we were airborne. He called abort, we aborted. All of us are safe. All of us are here to do it. Dealing from a position of life. I'll give you one more do it the way you brief story. That picture of the Udvar Hazy Museum with us sitting in the Airshow Center. When we left Udvar Hazy, you're taxiing out onto Dulles Airfield. Dulles has 3 parallel runways, one left, one right, or one center, one right, and then a 3-0 runway that kind of diagonals out to the northwest. We wanted 3-0 for takeoff because we were going back to Pax River. So we're going to take off, turn south, and just keep going south, get out of Dulles' airspace, turn off our talk and squawk, keep going. And so it was kind of one of these days where they had runways closed, and the left side was closed, and this was problems, and they're trying to get out the evening flights to Europe, and et cetera, et cetera. And took us 2.5 hours to get to the hold short line. And the airplane can't idle for that long. So you taxi forward 50 feet, you'd shut it down, let it cool down, start it up, taxi forward 50 feet, shut it down, let it cool down. 2.5 hours later, you get to the hold short line. So clear for takeoff on 3-0, so we're going to take off like that. We set the power at 30 inches of manifold pressure, which is where we do all of our checks. Everything's perfect. RPM's perfect, oil pressure's perfect, every temperature is in the green, cals are set exactly the way we want. And I look down, and the right engine manifold gauge has got a little tiny tick to it, about plus or minus less than an inch of manifold pressure. And I turn around and talk to my co-pilot. I'm like, Muddy, I've never seen that gauge do that. I said, are we losing the gauge, or is there something going on? And he goes, I don't know. I mean, everything's perfect. There's no secondary indication. Okay. All right. I'll shut down on a secondary in half a nanosecond. But something like that. We've lost gauges before. We've lost RPM gauges. I mean, the plane's 65 years old. She's going to have a little problem. So he said, okay, let's go. Push the power up to 50 inches a minute. And now you can't hear anything, right? And those props are dead nuts on 2,700 RPM. Our manifold pressure is at 50.5 inches. And now that right gauge is doing plus or minus about 3 inches of manifold pressure. Everything's perfect. It's all in the green. So I look at him, and we're accelerating down the runway, and I said, I'm good with it. He said, I'm good with it. I said, no secondaries. Good to go. So we blast down the runway. We take off. We suck the gear up. I start my left turn out. I go to 1, which is first power reduction. You're going to go to 45 inches of manifold pressure and then bring the prop back to 2,500. And I reached up. The throttles are over your head in that aircraft. So I reach up and I grab the throttles, and I got them back about maybe to 48 or 47 inches. And that right engine just starts backfiring. Bow, 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 bow. I was like, holy shit, there's a secondary. So the gear's up, pull that thing up into a climbing left-hand turn. He declares an emergency with Tower. Tower, bless their heart, airline guys. They're like, oh, you want vectors to final for a, no, left, one left, full stop, I'll be there and whatever. And so now I'm looking at, now I'm through the 90, coming into one left, and they go, okay, yeah, you can have one left. One left's close, can you make the center? And I said, yeah, I can make the center, good. So I throw the gear out, Muddy looks out the window, still clean and dry, everything's perfect on the aircraft. We roll through the 45, he looks back out at the right engine. I'm trying to pull the power off, but now I got too much. And that right throttle is jammed. I'm stuck at about 38 inches of manifold pressure. Shit. So, I mean, here's the runway. So I reach up and I fuel chop number 2 engine. It starts to wind down. Just as Muddy looks at the gear and he goes, holy shit, there's a giant friggin' hole in the side of the engine. I'm like, no secondaries. It's perfect. Everything's in the green. Oil pressure is perfect. Everything is perfect. So I'm like, we must have blown a jug out the side of that engine. So I touch down on the runway. Of course, now the fire trucks are chasing us and all that sort of crap. And I find the first taxiway. I pull off, and she won't taxi on one engine. There's no nose wheel steering. I just differential. So I pull off on the first taxiway, shut it down. I'm like, all right, get out of the airplane. It was an engine fire. And what had happened, it's real difficult to see, but that little white tube that's up there, you'll see a little hole in it about that big. That was a drain hole for the supercharger inducted air into number 7 cylinder that's supposed to be like a weep hole to let moisture out. And the weld had given out and it blew that thing out. So now I've got 50 inches of manifold pressure blowing a fuel air mixture straight out onto the number 7 exhaust stack, and it lit off. And it probably lit off on the runway. We never got a fire light because all of that is forward of the firewall where all the fire warning elements are. But because we had a secondary, so the secondary was when I pulled it back and shifted that manifold pressure, it sucked that fire back into the intake and blew it out the carburetor, which was the backfires that we heard. But that was a secondary indication. But we did exactly what we briefed. You know, handle it as an airborne malfunction. We're going to look for a left downwind for the left runway, you know, et cetera, et cetera. And so I got to tell you, it was the longest 3 minutes I probably have ever spent in an Albatross. And we had one of the kids in the back was filming it, 47 seconds from backfire to touchdown. It was bam, 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 bam. But we did it exactly the way we briefed. We all walked away from that. There were 7 of us on the airplane that day. But you're dealing from a position of life. You do it exactly the way you're going to brief it. And that's where you've done all your planning anyway. Do it the way you planned it. So flying's a dangerous, so what's the bottom line? Flying's a dangerous thing, right? Plan the flight, fly the plan, contingency plan the hell out of it. Planning is everything, the plan is nothing. If you planned it well, then you know contingency ops. That's what happened to us. We planned it very well. We had rafts, we had radios, we had everything under the sun. We did not realize that the enemy was a piece of crap floating in the water that was going to sink an airplane. But all the rest of the planning that we had done kept us alive and walked us out of that. So leave yourself an out. Always fly what you're doing. Competent, trained flight crew, exactly as he was telling you earlier. Go train for the event. I had never trained to have a swerve like that on a runway, but by God, I'd trained for aborts. I'd trained for water landings. I've done everything in that cockpit you could do with it. Brief all your critical phases of flight, and then do exactly what you brief. Trust your crew members. I could have argued with Don. When he looked over, I didn't see a hole under my seat. I saw water all over me and crazy shit going on with my instruments on the dash. I did not see that hole, but Don did. Don called for the abort. The abort's what kept us alive, in my view. So trust your crew members to do their job and do it right. And then, the bottom line is Pegasus is gone. We're not able to fly that event that leaves for Europe in a couple of days. But every single one of us is home safe. So I got, after 6 months, 7 months worth of tears and arguments and sitting in the backyard with a scotch and a cigar and my wife saying, stop it. I'm finally okay with most of it. But that's about all I got. So anybody got any questions on flying airplanes or doing silly stuff? I'm here to try to help you out.
Well, what I would like to do first is a round of applause. And I know without checking that the guys online are applauding as well. JB, this is the second time I've seen this group, and I get choked up seeing it again. I mean, I'm drained just listening to it. So I certainly want to express, I don't have the words to express my appreciation for coming up here and doing this. It was a trip for JB to get here. You were in Texas a couple days ago.
Yep.
And as you guys heard me say before, and I think I've said to you, the purpose of our safety awareness meetings is to learn from what other people have experienced. And one of the things I like to do, since we both have a little gray in different parts of our head, is bringing the guys with a little gray in different parts of their head. Because if it happened to them, it can happen to you guys. Okay? So JB, I really appreciate you coming up and talking about that. Sure. So with that, who's got some questions for our speaker?
Yes, sir. Just a quick question. I'm sure you mentioned. Did you make up your own DOH/name?
No, absolutely not. We used the A216 Navy NATOPS manual for the aircraft. In fact, as test pilots, the first thing we did was go out and verify that NATOPS manual was still, in fact, exactly correct. Because we were using 100 low lead on an airplane that was designed for 150, 145, or 130, 100. So we went out and validated everything. We did training with all of the Albatross instructors in the country. Every one of them we went out and flew with. Every one of them said, with the exception of one, every one of them said, well, you have a single engine situation, the first thing you do is go to 105 knots and use that. Totally wrong. It turns out that 105 knots will get you 105 knots and you'll never climb away from the ground. You actually have to be at about 112 knots. And it took, you know, I don't know how many sorties to define what that number was for us. We would have to find that number. And that airplane will climb at 700 feet a minute. And that's close if we do 112, which is not very good. NATOP says your minimum is 105. But from training from other groups and everything else, airline pilots in particular, they go to 105. That was the most bad. So we started going back and retraining all of our Albatross pilots to go, hey, we take them out on Lake Congo. Every time we did a gaggle, we take them out on Lake Congo, do a PNC air demo, and then do single engine demo and show them how to make the airplane fly.
Yeah, JB, can we just stand over here so that this.
Yeah, I'm sorry.
That's good. They got it.
Okay. Yes, sir. Yes, ma'am. Sorry.
Exactly how long from the notification of, okay, doing all that planning up to that?
2.5 months. Yep. 2.5 months from the time they called us and asked if we could do it, and we went and saw the buoys at Johns Hopkins. They had a time frame they had to meet and said, this is what we need to, when we need to put them in the water because of hurricanes and this and that. So here's our window, 2-week window. But okay, we could be ready by then. I mean, the airplane was working perfect. It was summertime, so we could jump in the airplane and go at any time. And we just groomed it up and did it.
So, Elisa, does that take you to be a lot or a little?
Well, the law added all the planning back in. Of course, very well experienced pilots,
Yeah.
pilots, of course. But when you kind of like get all of that, like, where did it
28 years of flight testing in the Navy and 26 years of flight testing in the Air Force.
Yeah. So for those of you that are online, the question was, how is it, correct me if I'm not phrasing this correctly, how did they do all this in 2.5 months, in only 2.5 months? And the answer is they've been doing this for a long time, and they're really good at it. Buddy was one of my instructors.
Was it? Okay. Yeah, Buddy's a great guy. Anybody else?
Other questions?
Yes, sir.
What's your next project?
That's a good question.
I think the question is, will your wife allow you another girlfriend?
Yeah, actually she did. She told me if I wanted to, we've been looking at G111s, which is a commercial variant of this. You know, my little quips at the FAA, we do not do well with the FAA.
Yeah.
The G111 is a standard airworthiness category Albatross. So we've been looking at that. It's coming in a little high for my budget. So it's probably not going to be a seaplane. We're probably going to go with something like a Twin Beach and find one of those in a barn and restore that and start doing that. Cool. So I don't think we're going to do another seaplane.
We did have a question online, more of a comment from Kevin Williams. Quoting, one of the biggest lessons I can see from your story, sir, is to maintain a calm head and keep your bearing and follow your planned procedures. But looking back and conducting an after-action report will make planning for the next time or someone else better and safer. So,
that's true. And hindsight being 2020, the answer on that particular thing of what did we do wrong, the answer was always fly your runway. Go back and back taxi, do 2 miles over the top of where you're going to take off. I think if we'd have done that, Pegasus would be sitting on the flight line. So.
And there's another question that has nothing to do with aviation, but roughly what was the depth, do you think, of the sea?
17,800 feet.
17,800 feet. Okay.
You know, hindsight's 2020, right? I mean, the Gulf Stream takes all the crap in the Gulf of Mexico, brings it around Florida, and then brings it up to the East Coast, right? And so every eddy that spins off of that, just like looking at your bathtub and watching the soapy water, everything lives in the eddy, right? So all the crap that's coming up the East Coast of the U.S. that's in that Gulf Stream lives in those eddies. Our job was to land right in the middle of the damn eddy. Every eddy, actually, our job was to put one of these buoys in every single one of those eddies. When the guys on the pole of Peru picked us up, they were like, oh man, thank God you weren't out here 2 days ago, the whole freaking tree, man, I need branches and roots. We're like, yeah, well, we just seen that. You know, I mean, I could have seen a tree. I didn't see the piece of telephone pole or whatever it was, right? But they're right. That area, the Gulf Stream, that's what it does. It picks crap up and floats it through the Atlantic. So pre-flight your area.
Edgar?
You mentioned videos of the events. Do you have the videos of the St. Thomas mission and things so?
You know, you can
Question
go
was,
to-
were there any other videos of the mission or the any of the
St.
stuff?
Thomas events and things. Yes. So you can go to seaplanecrossings.org on that chart, and they have that's not my website anymore, kind of thing. You know, they got guys who are doing all that. And I think they're still moving towards some of their things, but I believe that they have like a Facebook page that's linked to that has lots of pictures of St. Thomas and the Caribbean and what we saw down there. That was a very gratifying event for us because they had nothing. I mean, there wasn't a roof on a building in St. Thomas. We flew the entire island, went up Hurricane Bay. That place was just a disaster area. There wasn't leaf one on any tree. You know, 2 Cat 5s back to back. That place was just a mess. So that was a very gratifying event, and I think there's a lot of pictures on the Facebook pages for Seaplane Crossing.
Melissa?
Yes, ma'am. Buoys all work great. Yeah. Yeah, in fact, that was the highlight of the whole thing. You know, we put all of them in one spot instead of one of them in 5 spots. But it turns out that we were so dead nuts in the center of that eddy that as we drifted out and moved, because we waited about an hour and then made the decision to put all the buoys in the water, all of them went in a different direction. And they got a huge smattering of what an eddy actually looks like down to 300 meters. So they were, you know, we didn't really blow it from that end of it, I guess, you know. And they sent a ship out from Bermuda. They actually sank the buoys and let the next hurricane go by. By the way, that was a weekend event nominally. By Wednesday, the seas were 44 feet at the location where we left Pegasus. And they sank the buoys to 300 meters and left them there for 2 weeks and then managed them to come back up and then kept taking data. And then they picked them up from Bermuda. It was a 300-mile trip out of Bermuda. Go pick them up and bring them back in.
So like good test pilots, you got the data.
We got the data. That's it. Anybody else?
Let's see. That looks like it's it.
Okay. Well, thanks for letting me come chat with you.
Oh, JB, thank you.
Oh.
Another round. I'll see if I can do the other kind of round for you. We'll do the other kind of round for you. All right, thank you, JB.
Yep.
And thank you, Roger, who's still here.